training a virtual drone to fly here on Machine Learning Basics. Hey everybody, Blake here. It's been a little while, but we have another cool video doing machine learning goodness. So in this case, I had a different project that I wanted to work on, and I wanted to have a little drone flying around. And instead of going through and doing all kinds of crazy stuff with the drone script, I figured, hey, I'm just going to teach something to fly, and if it's imperfect, it's imperfect. It's okay for what I'm working on. And we'll just kind of see how hard it is to build a virtual drone and have it fly around. And in comparison to some of the previous things that we've done, it really wasn't that bad. So I'm actually going to blow through. We got 4 main scenes, 4 scripts that show the evolution of this drone as we did it. So instead of being 4 videos, this is going to be 1 video. And so we're going to start here. This is the float scene for the drones. Now this is a version back when we were originally doing the lunar lander. We had like the simplest scenario that we could think of, which was having a white box and move it onto a red marker, and that was it, right? So it was moving in 1 dimension, and it looked a whole lot like this. And in fact, we reused for this project a lot of that code as our starting point, because we have a drone and then we have some place that we want the drone to fly, and so we start in the Y dimension. The script is fairly straightforward. You have the thing that you have flying around, you have the target, you have some minimum and maximum randomization for it. In this case, I did skip right ahead to using rigid bodies, and the input from the ML agent provides a parameter of how much force to use, and then also we have a reward scale. We have the rigid body so that we can add force to it, and then based on the last series of videos where we did, and we found out that measuring progress was more valuable than measuring distance. In this case, I'm comparing the distance between step to step so that we can provide the algorithm with an idea of how much progress it has made. And that does seem to simplify training significantly. So on start, this is just initialization where we're picking up the rigid body, and that way we can add force to it later. When the agent gets reset, we make sure to turn off any velocity and rotation that the rigid body has picked up, and then we pick a random position for the marker and a random position for the target, again within those bounds, plus or minus 1 meter in this case. And then since we're just starting out, and again we're measuring improvement, right, we say that we initialize with the current distance is the starting distance, so that on the next step it has a proper idea of how much improvement it has had. When we collect the observations, we find the distance between the current drone and its target, and then we also provide as an observation the velocity and the rotation. Now in this case, we don't need the rotation just yet, but I just put it in there, and so we just had it ready to go in future states. So this is 10 observations, and I think the final version ended up with 11 floats. So this is 3 for position, 3 for velocity, and 4 for rotation. And then the agent action, so this is what we're doing. First, we're checking to make sure that our vector space is in the proper action space type. And then, since it can only go up or down, right, it's just thrust. And so we only have the 1 action, and then we clamp the action from -1 to 1. and we calculate based on the previous amount how much up-force does that equate to. So yes, what's interesting about this is it can actually thrust down if it wants, but in most cases it just lets gravity do that, so it doesn't thrust down, but it could if it wanted to. And then we add the force to the rigid body. We calculate the reward and we set the reward. And in this case, the reward is very simply what is the change in distance to the marker. So if you got a lot closer, then it's a lot more positive. If you got further away, then it's going to be negative. And that's pretty much all there is to that. And it trained beautifully. So again, there it is running. And then we have... I think we're actually, yeah, I was able to train this first shot. And so you can see here that it was able to just learn it, and it was no problem whatsoever. So 50,000 iterations, and boom, it was done. The next one, Drone Hover Brain, you'll see that there's a couple of versions of that. That's usually when I'm finding bugs as I'm working through things, and then we'll start another training. So in the case of the hover, what's going on here is our drones are a little different, right? We have our main body, and we have our 4 thrusters to each side, right? And so front right, front left, rear right, and rear left. And so each of these are spheres with their own mesh renderers and sphere colliders. And the idea is that each of those is a thruster. So the input from the agent is gone from a single up on the center, and in fact is now 4 different values that get applied at the thrusters. But the rest of the problem remains the same. It is trying to only go up. The cube will only be directly above the drone. So let's take a look at some of the code for that. So again, where's the marker? What's the target? Where are the thrusters? We need those so that we can apply the forces correctly. The heights are the same, the force is the same, reward scale is the same. Energy reward scale, so this is also, I was playing with, I wanted to penalize it for using too much energy. I think in this case I downplayed that significantly. Yeah, so it's only 0.01, right? So it's just this very small factor that when it's optimizing, right, that's something that I can optimize. So this says 0.25, but in the actual prefab it's 0.01. And then the visualize is just to visualize the environment. I didn't really use it, so we're just going to skip over that code. And then the rigid body for the marker, and then again, previous distance, start position. So self-initialization, start position, this is all pretty much the same, right? We reset, stop it, make sure that we're not carrying over any velocity or rotation from the previous run. Again, initializing the marker, start of the game, previous distance, and then we're going to skip over to the visualize. The observations are exactly the same as they were before. In this case, we have 4 actions, right? And so we have the up force for each of the 4 thrusters, and then we also have the energy used, which is the absolute value combined divided by up force. And there's a bunch of different ways that you could do this if you were super concerned about optimizing energy used. Let's see here, marker rigid bodies. These were, again, we've gotten the inputs, so now we're adding the force at the position of the thruster. And then reward, we're calculating the reward, and so we have the improvement, so how much closer have we gotten, and then there is the energy reward scale, so we have the energy portion. So we're doing one calculation for how much have we improved getting to the marker, and then the other one for being energy efficient. And again, so when we play this, go ahead and see these guys come up, and they do this like flutter thing, which I never totally got rid of, but it looks pretty good. I mean, they're staying on the marker, right? They can move in 3 dimensions, but really they're just moving back and forth in one. And I will actually turn off maximize on play and do a side-by-side real quick so you can see that when we do this, we have one of these guys. If I can pick up his destination marker. He's making it hard. Come here, you. There we go. Right? And I can move that up, I can move that down, and it follows, and it tries to stick with it. So that's really good. I was very happy with that, and that took a few tries to train, right? And so sometimes you'll see that I just screw up and realize early on the training process I've screwed up, and so I'll stop it. This is the first full training run, and that is a gorgeous curve, clearly going asymptotically. And then, yeah, so these are all the hover variants that I've done. And I think a couple of these variants had different energy penalties. And so, yeah, you can see a couple of them I terminated quickly, and then this one I just let run overnight because I was going to bed and I wanted to see how well it did. And so that's the one that I ended up with. And, you know, if you zoom in on it, it never, you know, reaches perfection, but it, you know, spends a lot of time optimizing as it gets closer. So I was pretty happy with that. So then we need to add movement in more than just the one direction, right? So we're going to go fully three-dimensional, and so this is the directional version of it. And so in this case, we have something similar, and you'll see here even in the script I said, oh yeah, we're going to downplay the energy reward. The grace distance, this is when it's close enough to the target that it gets a bit of a reward. Aside from that, this script does not change much, right? Initialization, again, previous distance, ignore the visualize stuff. Collecting observations, so I do provide more information in this one. So distance to target, current velocity, and then the quaternion. Let's see here. And then again, the agent takes an action, right, for each of the thrusters. We calculate the up force, we calculate the energy used, and then we apply the forces, we calculate the reward, and we set the reward. And again, we have an improvement portion and an energy portion. So this is largely unchanged from before. But you will see that, sure enough, it flies around and they do stuff. And I can tell I have the visualize on because it has the little black markers, which just were supposed to give me an idea of the reward field. But that was actually a carryover from the Lunar Lander script stuff that we did. Now, so how did we do? Well, I can move this reward around, right? And that looks really good. It's this guy in the back. Now this is based off of absolute position. And one of the things that's interesting about that is that when you're messing with this guy, if it's very far off, right, it's not doing it based on the direction it needs to go. It's doing it based on the distance it needs to go in each of the three axes. Now the information contained in each is actually largely the same, except that when you're doing a distance, what will happen is if you're far enough away, you'll give it a distance that's outside of its experience, and then it won't know what to do because it's never seen numbers that big before. And so one of the things that I did is in the next version, I also normalized all that so that, or no, in this one we normalized that. So in the previous one we didn't, in this one we did, so that when it gets input, it's getting the direction to the target, not the location of the target. And that allows it to have arbitrarily large distances, and it will still try very hard to stick with it. So it does a pretty good job. Every now and then, oh, there it goes. Every now and then one will crash if you move the marker too fast or something like that. It's not absolutely perfect, but it's pretty good. Now, there is one other big downside to what this learned to do, which is when you move it, especially over larger distances. To get to the target, oh, there goes another one. Part of the problem here, and part of why they're falling out of the sky, is that it has learned that when you move it, it can go down and then it goes back up. And so it's not the most efficient route, and when you're in an environment that has geometry and it goes down like that, it'll bonk into things, and it'll crash or similar stuff, or sometimes it'll dip down too much, and what'll end up happening is it'll pick up too much downward velocity and it doesn't recover effectively, which is part of also why they are falling out of the sky like that when I move the marker a lot. If I move the marker only a little bit, it seems to be fine. It's just when I move the marker quickly, it has some issues. So I thought I would have solved all of those issues with moving to direction, but it didn't quite solve them all. This might be a place where Academy learning is really good because you can step up the difficulty over time. For the project I was working on, it wasn't really that important. All right, so finally, I didn't love the movement that I got in the previous ones, so I wanted them to fly a little flatter. And to be a little more conservative with how much movement they did in the Y direction. And so I did a training. I'll pull up the tensor board. And so, yeah, for the direction brains, you can see I did a couple of trainings with it, and they both trained pretty quickly. I mean, this is 100,000, 200,000 range, and it was trained. And then after that, it's just optimizing. And again, I just let them go overnight. Let's see here. So the drone height, yeah, so this is the one where I was worried about its height. So I will go ahead and move the main camera, stare at this little guy, or close to it. Yeah, there we go. Right, so you can see there, in that case, it swooped down, but it didn't have too much of a problem. And so this was trained, basically there was just a floor, right? And so it was 10 meters away, and then if it was below that, it got a penalty for flying too low. And so early on, when it was doing the first training, it would find that floor, and it would have issues with that, and it wouldn't want to fly below that in future things. So it does a very good job. Although, so there's another problem where when I get close to that floor, right, when I've told it, that your floor is 10 meters away, let's see here, so it'll be about negative 10-ish, right, up there it goes, right? So now it gets below that floor, and it's learned not to go below that floor, but it finds itself that it is below that floor, and it doesn't know what to do, and it still does crash if you go really, really low. But that's not the end of the world, because what I did is when I took this code, right, I got it working in this environment, and then when I put it in my main project, I was able to just use the, I had a terrain, right, and so I was able to modify the agent a little bit so that I was giving it new minimum altitudes based on the terrain. And so what would happen was, below a certain height, it would resist trying to go down, and touch the terrain. It wouldn't want to do that. And then also as part of the logic, I said when I assign it a location, I base that location off of the terrain, the Y distance, so that it always stays at a comfortable altitude above the terrain. And so I've never had a problem where it actually crashes. So they're doing just great. So this is my little drone, and yeah, they, as of this one, with this height one where it tries not to lose too much altitude when it changes things, it never gets into that state where it just kind of dips too much and then loses control and falls off the world. You can still get them to crash, as I said, and you make them go way too low, or some other conditions where I haven't figured out exactly what it is causing them to crash. But these guys have been pretty stable. I'm very happy with them. I went through, did some polish, made a nice little scene for that. I used ProBuilder, post-processing stacks, ProGrids, so all default Unity packages that you can just go and add to your project. And so if you have any questions about that or how I did that, I am more than happy to go into that. I can make a video about how to take a very simple scene and make it look nicer using some of those tools and packages. In the meantime, if you have any questions, thoughts, concerns, please feel free to contact me. You can reach me here on YouTube, and then you can also, if you're one of my patrons, you can reach me over on Patreon. Unsurprisingly, I do try to prioritize my patrons over on Patreon. And then you can also try to get a hold of me on Reddit. I'm not on there very often, but I do try to swing by once or twice a week, just to make sure that I haven't left anybody out. So that's where I am with that. Speaking of my patrons, I'd also like to do a little shout out to FuzzBallBee. He posted a video of one of his ML projects, and in that case, it's a data center. It was based off of kind of a Google project that Google did with DeepMind, but the idea is you have traffic coming in and your computer is responding to it and getting hot, and you want to keep the computer cool but do so as efficiently as possible without breaking the budget by adjusting the cooling. And so he has a cool little demo where he goes through all of that, and then at the end there's a side-by-side where you can play against the computer, it looks like. And so that's at the end of his video where they got the fun little side-by-side, and you can see the ML agent just like rapidly tweaking with the air conditioning settings, which is kind of funny. So I do encourage you to go check that out. In the meantime, again, any questions, thoughts, concerns, feel free to get in touch with me. And in the meantime, good luck and happy learning.